Hello, ladies and gentlemen. We're going to continue working with limits. So we're going to start talking about techniques for evaluating our limits. So we're just going to learn different ways of managing the math, or the algebra primarily, so that we can evaluate our limits by hand. So let's just jump right in with an example. And I want to do the limit as x approaches 1 of x minus 1 over x cubed minus x squared plus x minus 1. And so if I think about my direct substitution, this is 1 minus 1, this is 0, and this is 1 minus 1, this is 0. Sad day, 1 minus 1 is 0. So if I did direct substitution, I would get 0 over 0, which is the indeterminate form. So I need to do some math to clean this up. So I'm going to start with your favorite F word. I'm going to start with factoring. Woohoo! And I'm going to factor the bottom using grouping. So I'm going to take an x squared out of the first two terms, and then there's a 1, and here are the next two. And then I'm going to write this as x approaches 1. Here's the x minus 1. I'm going to factor out the x minus 1, and I'm going to get x squared plus 1. So now these two terms cancel, which was the problem child, right? So I took away the indeterminate form. So now I have the limit as x approaches 1 of 1 over x squared plus 1. Well, now I can do my direct substitution. 1 squared is 1, so this becomes 1 over 1 plus 1 is 2, and I'm done. So the limit of the function as x approaches 1 is a half. So that one wasn't actually as bad as it looked like. Alrighty? So now let's do another example. Algebra is a little bit more fun. Same kind of deal though. So let's say I have the limit as x approaches 0 of the square root of x plus 1 outside the radical minus 1 over x. And again, if I did my direct substitution, I would get 0 plus 1 is 1. Take the square root of that, that's 1. Minus 1, 0 over 0. That's the indeterminate form, so I need to fix it. So one of the ways that we can manage a limit by hand is by rationalizing. So I'm going to write it over here. And before, we've talked about rationalizing the denominator, but now you can rationalize either, I'm going to write either, the numerator, or, I guess or would be better than that guy, the denominator. So the goal is to get rid of the indeterminate form. So I'm going to multiply this, I'm going to rationalize the top, square root of x plus 1 over the square root of x plus 1 plus 1. So remember, this is 1, it's just a cool 1, and I'm going to multiply it by this. The one thing that I will tell you that you almost never do is do not distribute, don't distribute on the bottom, because the goal is to get rid of some factors, and if you distribute, then you're not going to be able to get rid of factors. So don't distribute on the bottom, and then let's see if we can make this look better. So here's the limit as x approaches 0. Remember, I have to carry that notation until I get to direct substitution. This is a conjugate pair, so it's going to be the first thing squared, which is x plus 1, and then minus, because of this guy, these two multiplied together, 1 over x times the square root of x plus 1, guess I didn't need to be so long, and then outside the radical plus 1. If I simplify the top, notice that the 1's cancel, and now notice that the x's can cancel. And so now my function has become, as x approaches 0, 1 over the square root of x plus 1, and then plus 1. Well, now I can do the direct substitution, so then this is the limit as x approaches 0 of 1 over the square root of 0 plus 1, and the square root of 1 is 1, so this turns out to be 1/2. Alrighty, so that was actually pretty easy, but this is multiplying by the conjugate or rationalizing either the top or the bottom. You can call it either way. Write my nice polite statement when I'm done as x approaches 0 is 1/2. Alright, let's just move right along and do some more examples. I'm going to get a new page because our next one has a little bit more algebra in it. So for our next example, let's do the limit as x approaches 2 of 4 minus 18 minus x over x minus 2. And again, if I do direct substitution right here, problem child, so that means I have to fix it. So I'm going to multiply by the conjugate of the top because the top is the more complicated piece. So I'm going to multiply by 4 plus and then 18 minus x. Remember, I'm not going to distribute on the bottom because I'm hoping that one of the factors will disappear to eliminate the indeterminate form. So if I multiply through, remember you have to carry the notation. So 4 times 4 is 16 minus, and then I'm going to do the 18 minus x because the radical times the radical gives the underneath. And then I'm not going to distribute on the bottom, and I'm going to write 4 plus the square root of 18 minus x. If I simplify the top, I have the limit as x approaches 2, 16 minus 18 is a negative 2 plus x over x minus 2, and then here's the 4 plus the square root of 18 minus x. If you'll notice, these two guys are really the same thing, but they have the opposite signs, so I'm going to cancel them and leave a negative 1 on the top. Okay? Did I do my math right? 16 minus 2 is a negative 2 plus x. Yep, I did. Alrighty. So then now I want to look at my direct substitution. So here's the limit as x approaches 2 of a negative 1 over, and then I have the 4 plus, and then 18 minus 2. So this is a negative 1 over 4 plus, the square root of 16 is 4, so this is a negative 1 over 8. I'm just checking my math. I think I got it right. Write my conclusion statement. The limit of f of x as x approaches 2 is a negative 1/8. So that wasn't so bad. It just looked weird. All right. We have one more example, and then we're done for today. So this one is a classic example of a limit, and we'll talk about what I need to do first to make life better. So this is 1 over 2 plus x minus 1/2 over x. So right away, I notice that if I do direct substitution, I have a 0 in the denominator, and no bueno, so I have to fix it. So what I'm going to do first in this situation, because we got to love fractions, is I'm going to put the numerator together, and then I'm going to manage the denominator. So I'm going to multiply the first fraction by 2 over 2, and I'm going to multiply this guy by 2 plus x over 2 plus x. Okay, and again, I'm just managing the top at this point. So I have, here's the 2 minus, I'll put parentheses, 2 plus x over, do not distribute on the bottom, 2 plus x. And this is x over 1, so I can bring it up into this denominator. Okay, so I multiply by the reciprocal. So then if I clean this up, this is the limit, I ran out of room, as x approaches 0, of 2 minus 2. So here's a minus x over, and then I have 2, and then my x, and then 2 plus x in the bottom. The x's are going to cancel. I'm going to circle the negative so I don't lose it. So now I have the limit as x approaches 0 of a negative 1 over, and then 2 times 2 plus x. Now I can do my direct substitution because I've eliminated the indeterminate form. 0 goes in here, so this is a negative 1 over 2 times 2 plus 0, so the limit is a negative 1/4. Write your nice polite statement as x approaches 0 of the function is a negative 1/4. And then you're all done. Oh, I lied. One more example. It's a cute little guy. Alrighty. So the last one we're going to do some trig. And remember, we've talked about you have to remember your trig for calculus. So let's do the limit as x approaches pi of the cosecant of x over the cotangent of x. So before I get started, I'm just going to jump right into simplifying the trig. This is truly the last example. So then this is the limit as x approaches pi. Cosecant is 1 over the sine of x, and then cotangent is the cosine of x over the sine of x. I'm going to manage the fraction, so this is the limit as x approaches pi of 1 over the sine of x times the sine of x over the cosine of x. Those cancel, and then you can either rewrite this as the secant of x, but I'm just going to leave it as cosine when I do my direct substitution. So now I have the limit as x approaches pi of 1 over the cosine of x. If I do my direct substitution, the cosine of pi is a -1, so it's 1 divided by a -1, sorry you can't see. So then I'm done. So it actually wasn't as horrible as it looked, as x approaches pi of the original function is a -1. And now you're all done. Nice short little video. All right, guys, I will see you tomorrow. Hope you have a good day.